Welcome to Making PCBs with Chris Dayhut. For today's video, we're going to take a look at the design process before you actually start manufacturing the PCBs. Designing circuit boards or PCBs isn't that difficult of a task. There are very specific engineering rules, but for most of the knockabout circuit boards that us hobbyists would make, there's a lot of flexibility in those rules. So we're not going to focus on the engineering, but rather a piece of software that I use for designing the circuit boards. It's called Sprint Layout. I've been using it for many years. I've found it to be a very good piece of software that, for the most part, really does exactly what I need for my PCB manufacturing process. Let's take a look at how that software works. This is the Sprint Layout software that I use to design PCBs with. It actually has more capability than I use it for. Primarily, my PCBs are very simple and I can do layouts very simply in a manual process. Along the left here is where we would select which entity or graphic element we want to place on the screen. Down here is where I select which layer of the PCB I want something to be placed on. The color tells me where it is. Green is the bottom copper layer. Blue is the top surface, which could be copper or it could be just the substrate material. In this case, we're doing a single-sided PCB. The white is the outline that we will mill, and that width of that line represents the size of the cutter, so I see exactly where that cut line will end up being. Each of the elements can be set to a different size, and we'll go through some of that. Now we'll recreate this exact PCB over here off to the side so that you kind of understand what it is I'm creating as we go along in the process. The circuit board is very simple. I got a row of header pins here, 4 resistors here, going into an IC chip that I made up, and it's called GG123. And it's got pads on either side, and you'll notice that I'm going to be routing traces between the pads, and that's one of the trickiest things to do within making PCBs. It's easy to route them, but to make sure everything is small enough that it still conducts electricity and that your process can make it to that size. Over here, we've got a couple of transistors and then an LED over here. These 5 items are mounting holes, and they would be 1/8 inch diameter. They're actually a pad that I create on the top surface. We'll get started by creating our IC chip. To do that, all I really need to do is come up or create these pads on either side, and then I can draw a legend around on the inside. We'll get into that a little bit later. So I'm going to select, I got round pads here. I'm going to select round pads. That's a really large size, so I'm going to change that to about a 75 mil OD and a 35 mil hole in it, like so. And then I'll just lay those out along this grid pattern. The grid pattern allows me to snap locations, and it's currently set to a resolution of 0.1 inches or 100 mils. Oh, see, I made a mistake there already. I'm going to go ahead and delete those. I could move them, but I should have gone here and selected where I want that to be located. So back to pads, and now when I do it, they should be green. That would give me all of my pads for this chip, and I'll add in the legends and all that later on. So we've got that. Next up, I'm going to create our resistor pads going off to the right. And you'll notice that the hole is a little smaller. So when I select my pad, I'm going to make the hole smaller. I usually try to size the holes. Ooh, that's really wrong. Oh no, we're good. I usually try to size those holes close to the lead size so that the lead of the device or the component will fit in the hole easily and it slides right in, but not so loose that you end up with a gargantuan hole in a tiny wire. So we'll throw these pads in. Now we'll go through, add in our pads for the header pins, and these have a larger hole to accommodate the square pins that are on a header. So I'm going to select pad, update my size, like so, and we'll drop those in right along here. And I may need to move this over to the right a little bit. We'll try to squeeze in these other little pads in this area, these right off to the left here. Go back to a small round pad, and that would also have a small hole in it. And I would say that's about the right pattern there. Now I've got all these pads in place, and now we got to play connect the dots. And that's called adding the traces from one location to the other. Think of traces as little flat wires connecting all the components or whatever you want. Now right now over here you'll see that the green area inside my yellow cursor's halo is really large. I don't want my trace to be that big. It won't fit between all the different components. So I'm going to bring that down to about 25 mils. That would be 0.1 millimeters. And now we'll just go ahead and connect all the pads as needed to get our circuit correct. Now at this point my grid is 0.1 inches and I need to get between the pads here and here. So I need to change my grid to half of that, and now I can route between different pads. At this point, I've got the bottom copper layer all set for the isolation milling. And this is actually where the name comes from. We're going to isolate all these traces by milling a groove in the material around them. And that is specifically isolation milling. But incorporating this with all the other processes, we still generically refer to it as isolation milling. Now we'll switch to the top layer, the top copper layer, even though this particular example is a single-sided PCB. What I want to do now, I'll put in these larger holes here. These are the mounting holes, so that'll be a round pad. And I don't really care about how much copper ring is around that, but I'll just say 200 mils so that it looks a little different. And then the hole size would be 125 mils. So I'll just kind of get these out here. Of course, if you're making an actual PCB, you'd be very careful with where you put these so that it lined up with the hardware that you're mounting to. But we'll just get something that looks good for the time being. Now I want to check to make sure I put this one in the center, top to bottom, between these two pads. That's easily checked with the measure function. I'm going up 550 mils, and I'm going down 650 mils. So that tells me I got to move that guy down 1. And I'll check it again. 600 and 600. Now I need to add in my legends, and those will actually be engraved just like this lower copper area is. So I want text. I'm going to start out with my resistor values, R220. And I'll put that right there. I got 3 of them, so I'll just say OK. Size of the text can be easily adjusted, as is the orientation of it. So let's see, now we'll just drop that there. I'll click on it, cancel, click on it, and I'll rotate it around. Now I want the letters, the GG at the top. Like so. Move that guy up into the middle. And now I'm going to draw some lines in here representing the location for this IC chip GG123. So I'll make that 5 mils wide, and doesn't have to be perfect. It's strictly for visual. So I'm just going to go like so, back to there, and then run another bar there to indicate which end is pin 1 end. Now we've got it laid out with our legends and our holes that'll be for our mounting. The next step is to cut out the whole PCB using the outline function, and that's this layer selection here. And I'm going to do that by drawing a track. And my tool that I always use is 100 mils in size. And I can see I'm going to run into a little trouble right here with an overlap. So I'm just going to grab all this stuff, slide it over a little ways, and now I can go ahead and draw that in. And again, you'd be accurate with that so that you can get your components to fit inside your project correctly with the proper clearances. And there we have it. Might be a little bit bigger, but that's okay for our demonstration purposes. Hopefully that gets you a really good idea of how to design a circuit board. Simple circuit boards at that. Now that's not to diminish the importance of them. We can make all the simple circuit boards we want as long as they function and do what we need them to. So that wraps up this issue. Coming up next, we're going to take a look at the output from this design software and how I convert that into a CNC program. For the most part, it's a very fast, simple, and efficient process. I look forward to seeing you next time. Thanks for watching, and if you don't mind, could you please subscribe, give me a like, or share the video with others.